Hello. Hope you're having a great day. Happy Sunday. It's Sunday where I am, but happy whatever day of the week it is wherever you are. So you may have heard this term model context protocol, MCP. You'll be hearing it more and more. And it's an open standard that was developed towards the end of 2024 by Anthropic, who are the people behind Claude, as a way of giving AI tooling and agents capabilities to consume things via an open standard. So you can give it access to data, capabilities, services on the fly without the tooling itself having to know much more about it other than basically an interface definition of how to call it and what it does. And that's what MCP is. So if you're using AI IDEs, you'll start to see MCP options starting to appear in Cursor, Windsurf, or Cline, depending on your favorite flavor. Now, personally, I'm not a great fan of AI IDEs. That they're great for learning new technologies. They're great for answering a question about something you've never seen before in a code base you've not looked at before to say, okay, that's what that does. Great for proof of concepts. For juniors, they're not so great because, it's you can become very heavily reliant on it to the point that if you don't know from first principles what a technology is doing, it's very hard to police whether an AI has done a good thing or a bad thing, other than it works. And over time, that will create problems if you're not learning from first principles to be able to police that. Um, Again, the other reason I'm not a great fan of AI IDs is actually this is just the start of where we're going. Over the past 2 years, you'll see very early on that before agents were a thing, I've been using agents. Before COT was a thing, I've been using out of inference COT. It's now available in inference. And one of the things that also to be able to develop agentic networks, I've developed a standard, which is an internal standard for me to be able to allow these agents to talk to each other. So a standard set of interfaces that allow them to communicate, chain, do workflows, have definitions of what order agents should do things to be able to reflect, to be able to chat to each other. But of course, that's no good to me if I want to use it in third-party tooling. But what MCP allows you to do is it allows an open standard where you can create a server where you can expose these capabilities. So these hundreds of capabilities I've got now, I can expose certain ones to other toolings by defining an MCP server interface, exposing the ones that I want to expose and allow the AI to use it. So you can think of, there's quite a few things you can do with these. So you can give AI agents what I call limbs, which is capabilities to do functional things. So, for example, to be able to interact with your file system, to be able to do things to your file system, to be able to run things from the command line, to be able to run third-party applications and reflect on the emittance that comes back. And we've done that in some cybersecurity demos I've done where on remote compute, we've got it running tooling, doing things, and it's coming back. And the actual AI kicked off the tooling with the right parameters to do a thing it needed to do. And then it can reflect on the output without any need for a human intervention, as it were. And you'll see if you've been looking what's going on in this space this week, it's very much going the way that I've been talking about for 2 years now. I've seen very much for 2 years. It's not going to be about chat interfaces, type, respond, type, respond, type, respond. That is not where agentic AI is going in development. What's going to happen is you're going to define a task that you want an AI network to do. It's going to break it down into subtasks because it's very much for using agentic AI. You want to break big things into small things. You get the chance of a better outcome become much higher if you can do that. And at any stage, you can reflect upon something's gone wrong and ask for a human for help. So you may have a big task to develop this thing, and it may break it down into 10 tasks. And the thing with agentic AI, and you're seeing this with OpenAI Codex this week, is that if you can go away and spin up individual sandbox remote compute that can pull down the repositories and do work, it can do 10 things at the same time. They can go away and do things, but it's not just like, oh, I'm doing this thing. Oh, what do you think? I'm doing this thing. What do you think? It's very much an agentic network, taking a task list, breaking it down, spinning off agents to do things. At that point, it'll go away and write some code. You'll then have an agent that will reflect on the code. Does this look like a good answer? I mean, that's the first starting point to does it look a good answer? If you're using a less than premium model because you're wanting to save money, which is a very good strategy using agentic AI, if it doesn't look like a great answer, do we need to escalate this to a more premium model? So it can make decisions about, okay, that was a good enough answer for what we need. Let's move on. So apart from just writing it, then what does it need to do? Well, you need an agent then to go away and write some tests, or you can run it in reverse. You can do TDD with agentic AI and get it to write the test first and then write the code. But you need to have some tests for the AI to be able to basically determine if things are running. So the first test for it to do, does it compile? If it doesn't compile, that's often an issue you get with agentic AI. Oh, you did this thing and you got this error. Okay, I'll go and fix this error. It can run the code itself using a lim to go away and run the, in case of C#, the .NET build tools. Oh, I didn't build. What was the error? I'll go and fix it. I didn't build. What was the error? Go and fix it. Okay, it builds. Okay, now I want to test it. Okay, now I'm going to go and fire off another agent to write some tests. Okay, write the test. Did it run? Yes. What was the test results? Oh, this test failed. Oh, okay, there's a problem with the code. I'll go and fix it. To very much do what a developer would do. So eventually, if it compiles and the tests run, then it's got a reasonable sort of sense that things are pretty good. And then it can go even further with spinning up, for example, the UI and navigating the UI. And in terms of MCP capabilities now, you're seeing things like Puppeteer appear so that you can allow AI the capabilities to go away and use a browser to do things, go away and do search. So very much the world of agentic AI is very much going the way that I always thought it was going to go. And MCP is just a great way of an open standard now, which has always been required to be able to do things. The great thing that I'd love to see is an AI operating system where AI extendability is built into the operating system at all levels and all applications to then be able to create your own capabilities to do anything within your operating system. And at some point, we're going to see that, but that's probably another year to 2 years away. You're definitely going to see it. A bit like now you're seeing exactly what I thought was going to happen with agentic systems. The IDE is a convenience for the human. The AI doesn't need it. Now, you may want it to go away and do this task, and this task might take 20, 30 minutes and come back. And at the end, you might want to use the IDE to review what it's done and then talk to it, then go away and let it spend another 10 minutes going away, reflecting upon what you've said and fixing what you didn't like. That's very much the way AI works. It's very much less of a human interaction. It's not 50-50, it's maybe 5%. So this is where we're going with these things. So MCP is just a great open standard to be able to expose your capabilities or your controlled data stores. You can basically control what you expose to the AI network to be able to allow it to do things through this MCP server. You can control what data it can ask for, what data it can see. So it's very much a great open standard to be able to do things in toolings that you didn't write, but give it capabilities that you have written without obviously them having to add it as a capability themselves. So I thought I'd show you how to do this and how easy it is to do. Now you can do this in TypeScript, you can do this in Python. My orchestration is very much heavily focused on C#, so I'm going to do it in C#. So we go to the Model Context Protocol GitHub repository. There's now a C# SDK, so it's Model Context Protocol.official. They produce a NuGet package that you can go away and use this to very easily create an MCP server and also to create an MCP client. Now, you might create the server to use as something else like Cursor or Windsurf, or you might create the server to use yourself with your own client. So let's just show you how easy it is to build a server and a client in C#. So to save me boring you and me boring myself typing it, I've gone away and created one. Very simple. You see there's very little code here. So very much there's 3 dependencies here. So there's this one at the Model Context Protocol.official NuGet package, which is required by the client and server, just gives the capabilities to create the server, to create the client. And the client is very much like connected to a data store. You essentially have a connection string to connect to the server, and then you can go away and ask what tooling have you got, and then you can go away and call the tooling. And then the only other things we've got here, we've got logging, and we've also got hosting for the server because we want to host the server. So let's go away and have a look at the server now. So what have we got here? So we've just got some dependencies that we've added. So dependency injection, hosting, logging, and we've also added the Model Context Protocol server. So first thing, we're going to host the application. So we're going to create a builder to create an application builder to host the application. We'll add logging, and then we'll just add the requirements here for MCP, which is add MCP server with Studio server transport and with tools from assembly. And then essentially we'll run the host. So we've got a second class here. So I've just put it in the same code unit just to make it easier to see on the demonstration, where I had a couple of very simple capabilities to this server. So I've added user annotations essentially. So you define an MCP server tool type, and then inside of there, you define MCP server tools with a description. So I've defined 2 tools here, one that will basically create a SHA-256 on a string that we pass it, and one that just returns a simple version. So in terms of then running it, as soon as you run that, that will be exposed and available. And you can either host it permanently and then have it available. In this case, we're just going to spin it up interactively to be able to run a client. So let's go to the client. So very much you have a connection string, very much akin to a database connection string. So you're using, again, the client namespace of Model Context Protocol, using Studio Client Transport. And in this case, we're just going to tell it, oh, if you spin up this command, it will spin up a server for you to go away and do things. And then very much you just use a client, MCP client factory. So that's all we do, create a client. It's available then to use. Then we go away and use the list tools async to show what tools are available from the client. And then we go away and just return this static version string. and then you just use link to return the response from that. And it's very much metadata driven here. You can see that it's strings, not concrete types, because these things don't. It's all about AI is all becoming about metadata. Code is going to disappear. Metadata, metadata, metadata. So this thing is based on metadata, because it's very easy then not to have to compile something. You can expose something as data. You can go away and consume it. So the first thing we do is go away and just report this version. And then we go away and give the capability to ask for some text. And we go away and call the client to use the SHA-256 tool to be able to go and create a SHA-256. Now, other things you can do with this, obviously, you can go away and allow it to do things with the file system. And if you look in the MCP servers that are already available, the generic ones, there are things for doing with things with file systems, things for doing things with like Puppeteer for controlling browsers. But you can use this to expose your own data store and what things inside, entities inside your data store you want to expose to be able to allow AI to talk to it. So you can think of, in case of things like chatbots or things that are forms which are collecting data from a user or dealing with complaints from a user in real time, you can go away and you give it the remit to get certain types of data relevant to, for example, the case that an order that somebody's made. So you can, the AI can see the details of the order made and it can respond back, having context of that in a real-time scenario via text, via voice, via UI, building UI on the fly, which is what you're going to be seeing quite shortly as well. Code is going to go away a little bit with these very, very, very micro model type models. If you think a chatbot is very much a very noddy UI in some ways, you've got a static cursor where you're doing things. But of course, when you're asking for information, depending on what you're asking for, you can build the UI on the fly. And as long as everything's based on metadata, that's the way it's going to go. So that's what we've got here. So we can just fire this up now and we can see it doing something. So let's do that. So there we go. We fired it up, and you can see here that it's returned the IAM version 1, which is basically coming from, there's an MCP server function it's called. It's not part of the static code of the client. And then we've got some text here that we can enter. And so I'll put in hello world. It'll go away, call the MCP server. The MCP server has then created the SHA-256. So there you can see, that's it. We built an MCP server, an MCP client. Probably took me less than 5 minutes to throw it together. You can think of these very much like APIs, right? So, you've got an API and you've got Swagger, and you can add an endpoint to do this, an endpoint to do that, an endpoint to do this. So it's kind of like almost like an API for AI in terms of giving it capabilities to third-party code bases, for example, or third-party systems where you very much want to control what they can do in an open standard format. So that's really all I've got for you today. So bye-bye for now. Have a great day. Enjoy the rest of your day, and I'll speak to you soon. Take care. Bye-bye.